I am a second-year PhD student in the Department of Geomatics. My horizon has been broadened through my freshman year of college to second year of PhD. When I was an undergraduate, I joined the Student Association of my department, participated in planning various activities and learned spatial information-related theories from classes. Then, the department provides me with even more opportunities for overseas study and international symposiums. What is the Department of Geomatics all about? Let us go and take a look with the UAV. From the traditional measuring tape and manual drafting topographic maps to the optical high-tech surveying equipment, people are able to measure heights and angles more precisely. With the advancements in technology and the advent of digital era, we can record spatial information more easily with electronic equipment. However, the advent of satellite positioning is the major breakthrough which leads to the globalization of navigation system. Now, let us explore the secret of spatial information together. First stop, geodesy, the theoretical basis of geospatial information.
The word, geodesy, dates back to the ancient Egypt. People divided the land of Egypt into plots for the purpose of agriculture. Nevertheless, annual floods of the Nile River swept portions of these plots, and various surveying techniques were adopted for the re-subdivision of land after the inundation waned. However, accurate subdivision of land is complicated. Through various techniques and equipment, it was deduced that the planet is actually an ellipsoid and a coordinate system was developed to identify the location. Geodesy were applied in climate-related issues, including monitoring and analysis of crustal deformation, sea level rising, and earthquake warning systems.
Spatial information becomes globalized and we have specific researches in the field of global satellite positioning system.
Global Positioning System is commonly abbreviated as GPS, was the technology developed by the United States for military purposes initially, and it only became available for civilians afterwards. Each GPS satellite in the space continuously broadcasts a signal to the ground and users receive the signal from the satellite with GPS receivers. By means of processing the signals, we can calculate the distance between the satellite and the receiver, and to identify the location. In addition to GPS, other systems such as Russia GLONASS and China BeiDou form the Global Navigation Satellite Systems, GNSS.
The development of aerial photogrammetry and remote sensing leads to the enhancement of global mapping technologies.
Photogrammetry is the technology of obtaining reliable three-dimensional coordinates through photographic images. The traditional approach was fixing the camera in the aircraft to capture a series of aerial photos, and then produce the terrestrial stereo model according to the theory of the parallax. With the improved sensing technologies, information that is invisible to human eyes can even be acquired. The images obtained from remote sensing can be applied to the distribution of the vegetation, environmental change, and hazard analysis, and so on. In addition to traditional photogrammetry, the close-range technology is also matured. We use the panoramic camera to create a 360-degree dynamic panorama. With the precise positioning technology, the real-time positioning and surveying can be expected.
when we have a lot of geospatial data. By using GIS techniques, we can integrate and analyze these data more easily.
Geographic Information System is abbreviated as GIS is the combination of cartography and spatial information. The period between the 15th century and 18th century is the age of discovery. In this period, the development of the seamanship became the basis of the modern cartography. Spatial information are able to be stored in computers. We can overlay different thematic maps and integrate them into a system which enables users to search for locations, plan routes, and analyze commercial patterns.
With the use of laser scanners, we can reconstruct the three-dimensional scene and analyze the surrounding environments.
LiDAR can be used to reconstruct the real objects in the world. The distance is measured by illuminating a target with a laser and analyzing the reflected light. The spatial position can be calculated accurately, and a point cloud of the scene is generated. These points contain rich spatial information, which can help in scene reconstruction and environment monitoring and analysis. Moreover, we can build three-dimensional models from point clouds and print them out using a 3D printer.
Today, planar information failed to satisfy users. Therefore, the department devotes to the study of 3D cybercity modeling.
With the aid of photogrammetry, remote sensing, laser scanning and other advanced technologies, we can reconstruct three-dimensional scenes and create a realistic virtual world. Not only for displaying, but also for simulation and 3D GIS.
The department inculcates us with a better understanding of geospatial information. In the future, we are not only going to become a domestic engineering in demand but also can serve in international companies like Google and other geospatial-related companies. Finally, integrating various geospatial techniques makes Geomatics be able to reach everywhere.
Through the integration of inertial navigation system, GPS and various sensors, a mobile mapping vehicle van like Google car is built. The system including calibration, real-time high-accuracy positioning, and dynamic image browsing has the ability of mobile mapping and acquiring spatial information effectively.
Moreover, the department is also working towards diversity, from mapping by UAV to the most popular app development. We believe, in the future, we can see developed applications of spatial information.